welcome. Thank you so much for joining our session, HSMs and Key Management in the Cloud. My name is Sam Fansteel, and I'm joined by Michael Loger. I'll do a quick introduction of myself, and I'll let Michael introduce himself, and we'll get right into it and on this session here today. So thank you again so much for joining. Again, my name is Sam Fansteel. I'm the Principal Security Consultant with Coalfire. I've been working in information security for roughly 20 years and in information technology for 27 years. I've led a number of teams in both key management as well as payment technologies that have allowed me to really get a perspective on our challenges with key management in the cloud from a number of directions. My current role is as a consultant and auditor for Coalfire, and I audit against a number of security standards that relate to key management, both HSMs, both traditional, hybrid, and cloud environments. Michael?
Yeah, hi, my name is Michael Loger. I'm Director of Product Security and Product Management here in Entrust. I'm working for the crypto space and key management space for nearly 30 years now, starting from the German Navy over software developer for hard disk encryption to selling the stuff to producing the stuff, and now I'm defining the next generation key management solutions, and collected over the last decades a lot of questions, concerns, problems from the customers, and what is really the pain points when it comes to encryption.
Well, Michael, I think we're really together. We both had encountered the challenges from every perspective, both engineering, auditing, and product management for keys. For key management and cloud services. I know you've got some specific takes that you've been able to learn from your customers as well as your own exhaustive experience in key management. So I think I'd like to start out as far as their agenda, letting you tackle a few of those challenges. For our audience, I think I'll come in after Michael and talk some more about key management lifecycle best practices, introduce some of the work that we've done with CSA to try to capture some of that into several white papers, as well as introduce some of the efforts we've made within the key management working group related to HSM as a service. And then we'll try, Michael and I together, to give our audience some best practices and next steps for their journey as they work to solve these problems. Michael?
Yeah, for me, one of the moments where you have some moments where you learn a lot in a couple of minutes. And it was the last pre-pandemic RSA conference in the US. And there was a guy that I know for a long time, and he was a little bit desperate. It was Thursday, late afternoon, last day on the RSA conference. And he said, there's no key management system. I said, what's the heck your meaning? Why is there no key management? He said, yeah, look, they're selling me graveyards. And maybe I was looking a little bit completely confused. He explained to me, look, on a graveyard, you have a thumbstone and you can read a name and a start date and an end date and a religion. And this is exactly what the industry sells me today as key management. They have a key with a name and a start date and an end date possible and an algorithm. But this isn't helping me. This is just the technical problem of generating keys, secrets, or certificates. My problem is I failed an audit, and I'm fully in line with the auditor why I failed it. Little story, he's generating more and more keys in the cloud, AWS, Azure, GCP. And a lot of people are entitled to generating keys based. This is how cloud protects themselves. Instead of parameter security, we have encryption keys for S3 buckets, virtual machines, long-term storages. And all of those people generating keys yeah, that's fine. And they have no clue why this key exists. And the auditor said, guys, it's funny that you have keys that are called the Friday afternoon key and then the latest key and the brand new key. And you have no clue what these keys are protecting. What is the risk associated with the key? What does it protect? And the auditor also gives these guys a very challenging question that, how in the hell you're deleting a key? And that we never delete a key base. We don't know if it's still in use or it's still needed. And this is why the complexity about key management is improving. And let's be brutal honest, for most IT people, encryption is still black witchcraft. Yes, they heard about in the study in the university, but when they have to deal with it, they're looking in the internet for manual and hoping for the best that they did everything appropriate. And based a lot of these IT guys only need to do it occasionally, that when you encrypt a database, you do it one time and then you hope that it will work for the next time until you're retired or not anymore in the company. And the next one has to clean up the mess and maybe found out, hey, I don't have a password for the certificate. Where's this password? And we can't simply decrypt the database when they need to reinstall the database. So this challenge is increasing. And one of the things that a lot of people in IT still not recognizing is encryption technology is the glue of IT. In older days, we had perimeter security, but today, whatever we do, without encryption, nothing is possible. No communication will work in a secure way. And with the cloud, also no running of IT systems, storing of data will be done without encryption. We need secrets, certificates, encryption keys, API for encryption. All of this makes the IT world more complex, but also more secure. And encryption is the only mitigating solution for falling perimeter. And we all know the perimeter is falling. Encryption is compensating this. And we need to have solutions that managing it. So what we need is global solutions where I put the key management where I need it. That there's a lot of laws and regulations also that tells you the key shouldn't leave the country. But you need also a proper documentation. You need a compliance and risk management. That you need to know, hey, this is a test key. And this is a key that protects nearly my entire company. So there's keys that I need really to take care about. They should be properly protected by hardware security models, an example. I need a long-term repository where I will be capable to find keys even when they are long-term retired. That also governments has no concept of you don't find a key. This is a concept that governments don't understand. And then there's a term called CDSEC. This is from one of the biggest analysts on the planet. They told me, Michael, what you want to have and what this means is really the centralized, decentralized security. So the security objects are locally managed and can't leave the local environments in the local countries, but you need a global visibility of these objects so you can enforce global policies, local policies, and can measure, an example, how this key vault or the secrets vault or the certificates doing against local regulations, and also in parallel to your own company regulations. So key management is far more than key management. That a lot of solutions today and these days focusing only on the technical act of doing something. We have keys, secrets, but we have also standards, compliance regulations, we have vulnerabilities, we have laws and regulations that frequently changing. We need to have a proper documentation, and we need to have a risk and compliance management that tells us 24/7 what is going in the right direction and what is going in the wrong direction. And this ends in the result of we need process safety. What the maturity model tells us is we need to have safe, repeatable processes based on measured data, and we are capable then also to optimize processes, an example. So we have the databases that can encrypt: Oracle, Microsoft SQL Server, MongoDB, IBM DB2, Microsoft MySQL, and so on. We have public cloud environments that learned also the way that they have to encrypt the data of their customers. Then they learned the customer wants maybe to manage the keys. And then they learned also, the cloud vendors, that the customer maybe wants to own the key. So we have these different technologies like cloud encryption, bring your own key, hold your own key. We still have a lot of environments in private clouds. We have a lot of customers that needs privileged access and secrets management. We have a lot of customers that have their own application and want to implement their own tokenization, what is a form of encryption these days, and encryption. We have systems that needs to store for long-term data, and today we want also to have these data encrypted. That encryption ensures that the data itself are robust, and we need to take less care about the systems underneath. That one illusion some of the IT guys is, hey, when I patch everything, when I have the newest operation system, then I'm secure. No, you're never secure. There's mathematics, no evidence that you're 100% secure. This is impossible. What is possible is managing risk. But to managing risk, you need to know the value of the data, and when you're having the keys, you need to know what value of data these keys, secrets, or certificates are protecting. And with this, you can say, guys, we accumulate a risk that we can't manage anymore. So let's look how we can mitigate it. Sometimes it's simple. The key is very old, the certificate is very old, rotated. In another case, this agreement is not valid or is not anymore considered as secure, like MD5 or SHA-1. We have post-quantum and the elephant in the room. So we have a lot of algorithms that in the future may on risk. And we need this. So the term zero trust, crypto agility comes here in place to have a couple of these buzzwords that in the industry. But with this, the customer needs a partner on his side that understand encryption. And this is today hard to find. So when you have guys that understand encryption, keep them calm, make them happy. And then also find your vendor. We are one of the encryption vendors, but you can choose whatever you want. At least you have your vendor of trust where you say, this is my trusted advisor. This is my partner that knows my environment, and he knows how to make proper crypto management. The crypto management is a little bit like managing a group of small kids. You can manage 5, maybe 6 kids, but I never would be capable to manage a kindergarten. And crypto objects, a little bit like kids, they are small, tiny objects that very quickly the wrong hand. And then the problem is, when you lost control, you never will get the control back. And so this is why it's absolutely crucial to have the control, keep everything, and documentation is a very, very big part of it. Customer demands is simply, and this is a little bit going also in hand with our product that we are developing. You want to have local vaults that have keys, secrets, certificates, APIs like tokenization, but you need a system where you store the metadata of these objects and assign to this a documentation. Why does this object exist? Who was the owner? What was the purpose of this key? And the history. So this is key management that really deserves in the term of management. Current key management systems are simply storage systems, or as the guy mentioned from Belgium, graveyards.
Yeah, I've definitely seen, I echo that on the metadata. In my experience working with teams that are managing keys, it always seems that they have their key. They can show you where the keys are. They can show you, the checksum values. You can look at the configurations, but when you start to ask them, what's the usage of this key? What are your policies? Show me your logs. Their eyes start to glaze over and say, well, that's a different team, or that's, not something I didn't know you were going to ask for that. So there's a lot of just disconnect between managing the keys and then those things that actually accompany those keys to ensure that they're not abused and that their usage is in accordance with their prescription.
Exactly. And then another obstacle, especially for global working companies, and even in the US, we have a lot of states with different laws and regulations. We have more and more policies, compliance regulations, and they are changing frequently. To have a system that tells me that this algorithm, this key is violating, an example, the German law. One example, Germany will retire RSA keys that are worse than RSA 3K. So 3K is a new standard. So RSA 2K keys, 1K keys will be retired by end of this year. But you need to know this. You need to know that this compliance standard is changing. And this is also something that I think it's very arguable. A lot of the standards, like the ISO standards, you can only get these when you pay for it. So sometimes it's a little bit, I think it's a conflict to have laws that are based on compliance regulations that are not publicly available. So you need tools and systems that helps you to find out, hey guys, this is a key that sits in this country, or this maybe California. There's a new regulation that has changed it, and this means this key are not anymore valid. Also, you need to do an exception handling sometimes that you say, yes, it's not valid, but the limitation of my IT systems force me to keep it. But then I need to have an exception handling and a documentation. We come back to the point of documentation based on Germany. I love documentation and I love processes. And this is something that gets overwhelming to customers, that we have a couple of vectors that makes crypto so complicated. First of all, we have a lot of integrations. We have a lot of algorithms. We have a lot of industry standards, and we have a lot of countries and local laws. And then we have, hopefully as a company, our own standards. And this is in a world that gets more and more complicated and force more and more crypto. You need systems, and this is why key management is so important to help you to get control. Risk management and compliance, this is then the visualization against policy management. So with the documentation, you can calculate and should calculate a risk. In our systems, an example, we can tell you this key is outdated, it's not properly secured, it's exported on a Windows system, and the risk score is very high based on protecting a 5.6 petabyte Oracle database. So this is a key I should take care of, maybe find out how to mitigate this risk, and maybe I will buy an HSM and store this key instead of the flat file system in an HSM. Another key is also not comply, but it's a test key, and this is a low risk score. So why bothering with keys that have a low risk score? And this compliance management, risk management is the only way how to get control about your crypto objects. And this means also process enablement. In an automated world, only automated processes can keep up. So automatically, when people generating wherever they utilizing systems like cloud, AWS, GCP, and they may be generating a key. In Amazon, you don't even need to know that you generate a key. On every S3 bucket, Amazon creates a key for you. And then we need to have the documentation. And based on the documentation, there needs to be processes like, hey, this is a test key. So in 2 weeks, I will remind the guys to delete the keys. That test keys should not stay forever in the systems. It needs to be identified when policy violations are. An example, I have an HR key, and for HR key, I want to have hold your own key or Microsoft double key encryption, and inform them that the key, how he was doing it, is wrong, and this is a appropriate process. So he knows not only what not to do. It's like kids, never tell them what they shouldn't do. Every time tell them only what they should do. And this is super important. Key expiry, reporting. And then we have a lot of discussions about post-quantum encryption. And a lot of companies say, hey, yeah, let's make an audit. But an audit is like a candle in a cave. And then it's blowing out quickly, and then you need to remember where was the exit of the cave, and you need to switch on the candle again. Permanent monitoring is like a flash, a big light on the in the cave, so you 24/7 see where the exit is. And then I think this is follow my side. When you have key systems and storage systems that generating keys, you have keys that have higher security demand, and for these keys we need a layered security model where we have appliances or hardware models that gives us the possibility to have, like an onion, a couple of protection layers around my keys, and the highest iteration of this protection layer is in the hardware security model. where whatever you do, you never get the key out of this hardware security model. They are very important, an example, to protect public key infrastructures, root keys, root certificates. And this is where you also need to go and say, what is the vendor of trust for this highly sensitive crypto objects?
Well, you brought up a number of incredible points there, Michael, and I think that's part of why our industry is really starting to come together and both provide feedback to you, your customers, but also as you go around, essentially feeling the pulse of those that are dealing with the challenge of these highly diverse key management crypto systems. And in my world, yeah, I'm that candle in the cave. I get that opportunity to come in and say, okay, here's the things that I see. Here's areas for improvement. But then I'm off working with another client or working with another audit. And so we really need to have these, key management should be a life cycle, not just a life cycle, a birth and a death, but everything in between. We have to monitor all activities associated with that key, where it's being stored, both physically and logically, who has access to those components or shares. And the relics, the artifacts associated with these activities often is paper. Right. I see a lot of paper logs that are, okay, this is what happened on this day. Well, that's great. But, correlating those with actual, access control logs is a nightmare. And so a lot of key management that's physical in nature, because ultimately once the cryptography has associated with the encryption activity takes place, there's assuming you're using, strong algorithms and strong key strengths, you're safe, but it's all those activities that lead up to that. So as a part of the Key Management Lifecycle Best Practices white paper that we produced in the CSA Key Management Working Group, these are a lot of the topics that we really wrestled with, is trying to identify what activities are associated with the key lifecycle should be logged. What are those technical, operational, and financial considerations for investing or purchasing or utilizing a KMS system? And then, are there nuanced implications for deployment of those systems when you're dealing with both on-premises, hybrid, or cloud, or even multi-cloud systems, the compatibility, the usage of different key architectures. And we'll talk again a little bit about HSM as a service as we conclude. But we've talked about audit and operational impacts. HSM as a service was a separate white paper that we also created as part of the same working group. Many of the same authors contributed here, including some of Michael's colleagues. But in this white paper, we really are trying to put an industry best practices, but also shine the light on the nuanced implications of using an HSM from a cloud service provider versus using software-based cryptographic algorithms and libraries, which are, again, have their place, as Michael said, depending on the risk associated with these the keys and the underlying data that are being protected. You may find that HSM as a service may be overkill. But there are, because of the importance of using a hardware-based root of trust, as well as the physical protections of a hardware security module, which for those not familiar, ultimately is a cryptographic processor with validated algorithms and libraries that are encased within a tamper-resistant module, an appliance that actually will both detect and respond through the deletion of keys and erasure of sensitive data to any physical intrusion. Well, in a cloud environment, that's a little bit odd because you're using, the cloud, which is itself ephemeral or nebulous, I should say. But there is because of the independent laboratory evaluation and the importance of protecting those applications and keys within this hardware enclosure, we're seeing these two worlds come together for high availability, the interoperability, and extensibility of the cloud offering. So we've approached in this white paper a number of use cases, both in the enterprise payments and application space for PKI, certificate authority, and code signing, as well as just the established root of trust. So these are use cases that we've explored in the white paper, as well as specific to payments, which, let's be honest, is one of the larger, a smaller industry, right, on the global scale, but it is one of the larger use cases for the use of hardware security modules in the cloud. So we've explored a number of the payments cryptography use cases, as well as other specialized cryptographic use cases, such as full homomorphic encryption, blockchain, and the requirement for PQC, which often, because of its elaborate use and the importance of having laboratory evaluated and standards approved algorithms and parameters, it behooves us to use those within a tested HSM model. Now, I won't go into the details, but suffice it to say, as I mentioned a moment ago, that payments and general purpose HSMs do have their varied distinctions. But suffice it to say that as we look at vendors that are supporting the HSMs in their cloud service providing, the cloud service providers, as well as the HSM vendors and key management providers, there's a number of best practices around evaluating the vendors as well as the security offering to ensure there's a good fit with your enterprise, both the impact on legacy applications, as well as ensuring that you do have clearly delineated responsibilities and have proper segregation with other tenants of that cloud service provider. So as we come to a close, I just want to, from the CSA research forum, as well as from the Cloud Security Alliance itself, I want to say thank you to the working group that's helped support the content of this session, as well as the white papers. It's our intent to provide a support to the industry that's vendor agnostic, and we will be releasing the 2 white papers that I've mentioned at the end of this year. So please be on the lookout for that. And these white papers are currently, as I speak, in the peer review process. And so if this is an area of interest to you, I would encourage those of you watching here today to reach out, become involved, look at how you can become involved in CSA as part of any of the excellent working groups, or to provide peer review to these white papers before they go to print. Michael, I know you probably have some next steps for those that are feeling the pain of key management as well.
Yeah, for the pain of key management, honestly, when you don't feel the pain of key management today, you will feel it tomorrow. That one of the things that is clear is a lot of things follow an S-curve, like the invention of the cars, the invention of the smartphone. And we see now also with the falling parameter an S-curve in the numbers of crypto objects. And when you're starting to find that you have a pain, it's maybe already too late. So you have already a complete kindergarten and not only 3 or 4 kids. So starting the process, starting also to think about crypto agility, that algorithms changing, laws and regulation changing. We have the elephant in the room with post-quantum readiness. So crypto agility means I understand that today I'm using these algorithms, this kind of interpretations of these, and when something happens, I need to change it, especially when you're working in industries that have devices like cars or robots that's staying for 20 years. You have to know what is there, that when the algorithm is written in hardware, like AES in example 256 is typically supported by CPUs or microcontrollers, but the replacing algorithms, in example for RSA, they are not anymore on the microcomputer on the in the solution that you have. So you have to do it in software, what can be then end up in a performance problem, an example. So crypto agility is one of the terms. Zero trust without encryption is no zero trust. This is what I strongly believe. A lot of vendors tell, hey, this is zero trust, when I simply say this is not allowed for a customer. This is rights management. Zero trust means really with encryption technologies, I ensure that nobody can bypass other security methods. And when you need help, we are there. Entrust is the largest dedicated crypto company currently on the market. And we are, for a lot of our customers, a trusted advisor. So give us a ring, talk with your local partners, talk with your guys where you're thinking they are the crypto experts in my company, and have a plan. That without a plan, yeah, it's highly possible that it's end up like the customer in Belgium, where the auditors will say no, and you will not be audited.
Thank you so much, Michael, for joining me. Thank you, everyone, for joining the session. I hope that the rest of the conference goes well for you, and thanks a lot.